NASA's secret plan for a moon base. For decades, most people believed the moon was simply a destination, a place to visit, a place to explore, a place to leave footprints and flags, then return home. But what if the moon is actually something much bigger? What if humanity's future in space doesn't begin on Mars? What if it begins on the moon? Right now, NASA is working on a long-term strategy that could eventually place astronauts on the lunar surface for weeks, months, and perhaps one day permanently. Most people know about the Artemis missions. They know NASA wants to send astronauts back to the moon. But far fewer people realize that these missions are only the beginning. Because behind Artemis lies a much larger vision. A vision that could transform the moon from a distant world into humanity's first true home beyond Earth. And it all starts at one specific location, the lunar South Pole. For decades, scientists considered the moon a dry and lifeless world. Apollo astronauts returned with hundreds of kilograms of lunar rocks and soil. The surface appeared barren, harsh, hostile. Yet over the last 2 decades, something extraordinary happened. New observations began revealing evidence of water ice hidden inside permanently shadowed craters. Some of these craters have remained in darkness for billions of years. Sunlight never reaches their floors. Temperatures can drop below -230 degrees Celsius, cold enough to preserve ancient ice from the earliest days of the solar system. This discovery changed everything. Because water is not just water. For future explorers, water means survival. Astronauts need water to drink. Water can be used to produce oxygen. And perhaps most importantly, water can be converted into rocket fuel. Suddenly, the moon was no longer just a place to visit. It became a place where humans might one day live. This is why NASA's Artemis program is targeting the lunar South Pole. Unlike Apollo, Artemis is not designed as a short-term exploration project. The goal is sustainability. The goal is permanence. The goal is to learn how to survive away from Earth. Artemis 3 is expected to become the first mission to land astronauts near the South Pole. But the landing itself is only the first step. NASA wants to answer a critical question. Can the resources found on the moon support future human activity? If the answer is yes, everything changes. Imagine a future lunar outpost. Solar arrays stretching across the horizon. Pressurized habitats protecting astronauts from radiation and extreme temperatures. Rovers traveling across the landscape searching for resources. Scientific laboratories operating around the clock. Astronauts spending weeks or even months on another world. This concept already has a name, Artemis Base Camp. Although still in development, NASA has outlined a vision for a future lunar base capable of supporting repeated human missions. The idea is simple. Instead of visiting the moon once every few decades, astronauts would return regularly. Each mission would add new capabilities, new equipment, new infrastructure. Over time, a permanent presence could emerge. Of course, building a base on the moon is far more difficult than building one on Earth. The lunar environment is unforgiving. There is no breathable atmosphere, no liquid water, no protection from radiation. Temperatures can swing dramatically, and lunar dust creates additional challenges for machinery and equipment. Everything required for survival must either be brought from Earth or produced locally. This is where the concept of in-situ resource utilization becomes essential. Rather than transporting everything from Earth, future explorers may use lunar resources to sustain operations. Water ice could provide drinking water. Oxygen could be extracted from lunar materials. Construction materials might even be produced using local soil. The moon could eventually become partially self-sufficient. That possibility is one of the main reasons NASA continues investing in lunar exploration. But the moon base concept extends beyond the lunar surface itself. NASA is also developing Gateway. Gateway is a small space station planned for orbit around the moon. Think of it as a staging point, a transportation hub, a laboratory, and a stepping stone toward deeper exploration. Astronauts arriving from Earth could use Gateway before descending to the lunar surface. Future cargo missions could pass through Gateway. Scientific research could be conducted there. In many ways, Gateway serves as the bridge connecting Earth to the Moon. Together, Artemis Base Camp and Gateway represent the foundation of a future lunar infrastructure. And perhaps most importantly, they represent preparation for Mars. Mars remains NASA's ultimate destination, yet reaching Mars is dramatically more difficult than reaching the Moon. A mission to Mars could require years. Astronauts would face communication delays. Resupply would be nearly impossible. Every system would need to operate independently. The Moon provides a testing ground, a place where NASA can learn how humans survive and work away from Earth for extended periods. Lessons learned on the Moon may eventually help astronauts survive on Mars. That is why many experts describe the Moon as humanity's proving ground, a place where we learn before we venture farther. But significant challenges remain. One of the biggest involves transportation. NASA's current architecture depends heavily on SpaceX's Starship system. Starship is expected to serve as the human landing system for Artemis missions. The vehicle is unlike anything used during Apollo. It is larger, more powerful, and designed to transport substantial cargo to the lunar surface. If successful, Starship could dramatically increase the amount of equipment delivered to the Moon. That capability is essential for constructing future infrastructure. Habitats, power systems, scientific equipment, construction materials, all require transportation. Without reliable transportation, a lunar base remains impossible. This is why Starship's development is being watched so closely. Its success could accelerate NASA's long-term plans. Its delays could affect mission schedules. Another challenge involves energy production. A lunar base requires continuous power. Fortunately, the South Pole offers unique advantages. Certain elevated regions receive sunlight for extended periods. Solar arrays placed in these areas could provide reliable electricity. Future systems may combine solar energy with other technologies to ensure uninterrupted operations. Radiation protection remains another major concern. Unlike Earth, the Moon lacks a strong magnetic field. Astronauts are exposed to increased radiation levels. Future habitats may require specialized shielding. Some concepts even suggest covering habitats with lunar soil to provide additional protection. Every solution introduces new engineering challenges. Yet none of these challenges appear impossible. Difficult? Absolutely. Expensive? Without question. But impossible? No. And that is what makes this moment so fascinating. For the first time since Apollo, humanity is no longer talking about briefly visiting the Moon. We are discussing how to stay. The difference is enormous. Apollo proved that humans could reach another world. Artemis aims to prove that humans can build a future there. Whether that future includes permanent settlements remains uncertain. Whether lunar resources can support long-term operations remains uncertain. Whether future generations will live and work on the Moon remains uncertain. But one thing is becoming increasingly clear. The Moon is no longer viewed as the end of a journey. It is becoming the beginning of one. And if NASA's plans succeed, future historians may look back on this decade as the moment humanity took its first real steps toward becoming a multi-world civilization. Not on Mars, not in deep space, but on the silent, dusty surface of the Moon. A world that has watched humanity from afar for billions of years. And a world that may soon become our first home beyond Earth.